So in this example, we're given a graph, we're given a function, and we're asked to find all real and complex zeros. Real ones are where they're crossing, but the complex ones you're not going to be able to see on the graph. So when they bend, when the function bends and doesn't go through the x-axis, that means there are imaginary zeros that we can't get just by looking at the graph. But what we can do is use the graph to help us get those other ones. So there's this process where, all right, we can look at that and see that 2 is a real zero. But then the imaginary ones are happening down here with the bends that are happening here. This is a cubic function. So again, notice how there are 2 bends and there will be 3 total zeros, one of which is the real zero of 2. You can confirm that 2 is a real zero by substituting 2 into the function and getting 0. You can do that, but you can also just do synthetic division because you'd be confirming the same thing by doing synthetic division with 2 as your number in the box and getting 0 as the remainder. When that happens, when you see 2 as a 0, that means x minus 2 is a factor. What's left over is x squared plus 3x plus 3. We already know that the other 2 zeros of this function are imaginary by looking at the graph. So while you have many ways to solve a quadratic, since you know that the zeros are imaginary, you don't need to bother trying to factor. It's not going to work. So you're going to jump straight to quadratic formula. When you do quadratic formula, you get negative 3/2 plus or minus root 3 over 2i. So that means your 3 zeros of the function are the 2 that we found originally by looking at the graph, and then negative 3/2 plus root 3 over 2i and negative 3/2 minus root 3 over 2i. So those are your 3 zeros. Here's one that you're going to try on your own. Similarly, you can see where one of the zeros is real. The other 2, again, there's going to be a total of 3. The other 2 are going to be imaginary. So what you're going to do is synthetic division with that 0. And then you can do quadratic formula with the resulting quadratic polynomial that comes out of it. So give it a try and then come back and we'll check it out. The first thing I did is recognize that it's crossing through a 3, so that's where that 3 comes from. Doing synthetic division with the coefficients of the original function, those are all noted here. When I do synthetic division, I get 0 for the remainder, which means I was right to assume that it went through 3. Then these coefficients all tell you what that quadratic is going to be. Again, since you're only seeing it cross once, 3 is the real 0. This is going to give you an imaginary, well, 2 imaginary zeros, a pair of imaginary zeros. So I do quadratic formula with that straight off because I know it's not going to be factorable since I know that the zeros are going to be imaginary. I find the discriminant first, which is negative 20. Take a square root of that, and you get 2i root 5. Build the rest of the formula around it, you get 2 plus or minus 2i root 5 over 4, which reduces to 1 plus or minus I root 5 over 2. I'm leaving it as this statement. If you want to separate it out, that'd be okay. When you're doing your practice on Math Excel, you just have to follow directions and make sure that you're inputting whatever it's asked, the way it's asking. So if it wants it separate, like 1/2 plus or minus I over 2 over 5, or if it wants it as the plus or minus as 2 separate zeros, and you got to input it that way. But it all means the same thing, and this is how I'm choosing to write it. And if you're turning something in on paper or pencil, then you could do any of them. But again, just follow directions on Math Excel, so that way the format is not your problem. Okay, let's take a look at the next part of this example. With this one, you're seeing it cross twice. So there's 2 real zeros, but then you're also seeing 2 bends down here. So there's going to be 2 imaginary zeros, which makes sense because there should be 4 total based on the degree being 4. What you can do is first try, well, it's not going to be, you can't factor this like a quadratic because you're going to have, well, actually, is there something that, hold on. So multiplies the -4 and adds the -3. Yeah, you actually can factor that like a quadratic. So let's do that. So you have x to the 4th minus 3x squared minus 4. So what I mean by factor it like a quadratic is that's x to the 4th, you got x squared here and here, but you're just going to factor, like what multiplies the -4 and adds the -3. So it'd be -4 and it'd be +1. Right, that pair of numbers multiplies to that pair of numbers adds to that. Nothing else you can do with this, but this can break into, since it's a different squares, x plus 2 and x minus 2. So that's the thing fully factored. You can get 2 zeros out of it, the -2 and the +2 that you were seeing up here anyway, but then this is giving you the imaginary zeros that you're going to need. Now, you don't necessarily need to do quadratic formula with this. You could, but since it has no linear term, you can set it equal to 0 and solve by taking square roots, meaning subtract 1, and then take a square root of both sides, and you get x is equal to plus or minus the square root of -1, which is I, right? So x is equal to plus or minus I. All right, so I guess I'm not leaving this one for you to do. We just did it together. Okay. But anyway, your zeros are x is equal to, and you can write it this way, plus or minus 2. You got the positive and -2. You don't need to separate them if you don't want to. And then plus or minus I. So you have those 4 zeros, right? You got 2, -2i, and -I. All right, let's take a look at the 4th example.